Good morning, everyone. We are Larana Inc., and this is our group presentation for ITT300. Today, we'll be discussing packet tracing, what it is, how it works, and why it is matter. Before we dive in, let me quickly introduce our team. We have myself, Amirul Aiman, Muhammad Akil, Umay Skanda, and Muhammad Lokman. Together, we work on this project to bring you this presentation. Next, let's look at our network design. We use a star topology for this setup. We have two switches connecting LAN A and LAN B with 10% computers in each LAN, making 20 PCs in total. The network also includes one router and a DHCP server. Both LAN are interconnected to router R1 and R2. So, why did we choose star topology? There are four main reasons. First, reliability. If one cable fails, then the rest of the network stay up. Second, scalability. We can easily add more devices. Third, performance. Each device has its own dedicated connection. And finally, easy troubleshooting. Issues are isolated and simple to identify. Now, here is our IP addressing scheme. This table shows all the devices in our network, routers, switches, PCs, and the server, along with their assigned IP addresses, subnet masks, and default gateways. In total, we have 26 devices, including 2 routers, 2 switches, 20 PCs, and 1 server. All configured will specify IP as listed here.
So now I will be presenting on how to design our subnetting IP addressing scheme for our project. So we have given the network is 172.16.0.0 and our default class is B and the default subnet mask is 255.255.0.0 or /16. So for our number of subnet we required is 4, which is the one link, LAN A, LAN B, and also the server network. So for the step 1, we need to find how many bits to borrow. So for our formula, we use is 2 to the power of n is greater or equal to the number of subnets. So as we can see here, 2 to the power of 2 is equal to 4. So the n will be 2 because the 4 is the number of subnet we require. So for the step 2, we have the default prefix, which is the /16, and we need to add the borrow bits. So 16 plus 2 is 18. So our new prefix is /18, and we need to convert it to decimal first. So for the first octet, we have 8 bits. So it will be equal to 255, and the second octet is 8 bits, also equal to 255. And the third octet, we have borrowed 2 bits just now, so it will equal to 11000000 equal to 192 in decimal. For our fourth octet will be 0 bits, and for our new subnet mask will be 255.255.19.0. And step 3, we need to find the new subnet mask. We need to find the increment in the block size. So the value in the third octet of the subnet mask is 192. We need to put it in the formula. So the formula will be 256 minus with 192. It will equal to 64. So for the increment will be increment by 64. For step 4, we need to list all the subnet address starting from 172.16.0.0/18, and we will need to add the 64 to the third octet. So for our first subnet, which is the subnet 0, it will be 172.16.0.0/18, and for our second subnet, subnet 1, will be 172.16.64.0/18, and for our subnet 2 will be 172.16.128.0/18, and for our last subnet, which is the subnet 3, will be 172.16.192.0/18. And then for the step 5, we need to find the one link subnet, which is the /30. the one link between R1 and R2 needs a /30 subnet, which is only 2 usable hosts, and then we take the first subnet 172.16.0.0/18 and sub to the subnet it to /30, and then for the /30 it only need 2 usable hosts, so we need to insert it in the formula. The formula will be 2 to the power of 32 minus 30 minus with 2. So the answer will be 2, and we will subnet from 172.16.0/18 to /30. And then first, the /30 subnet, which is the 172.16.0.0/30, we will need to calculate the /30 increment. So the calculation will be 256 minus with 252 equals to 4. But we only need the first /30 subnet. So as you can see here, there's an table for the address type and the value. So for the network address will be 172.16.0.0, and the R1 is 0.1, and the last host R2 is 0.2, and then for the broadcast address is 0.3. So for the step 6, we need to find the usable host per subnet. So we need to put in the formula. The formula will be 2 to the power of 32 minus with prefix length minus by 2. So it will be 2 to the power of 32 minus 18 minus 2. So the answer is 16,382, and each /18 subnet has 16,382 usable hosts. And then for the one link /30, the formula will be 2 to the power of 32 minus with 30, and we need to minus it with 2. So the answer is 2, and we have concluded that the one link has only 2 usable hosts. Step 7, we need to assign the subnets to the network. So we have 4 subnets. Subnet number 0, the address will be 172.16.0.0. The mask is /33 from /18, and it will be assigned to one link, which is the R1 and R2. And for the second subnet, subnet number 1, the address will be 172.16.64.0, and the mask will be /18, and it will assign to LAN A. And also subnet number 3, which is the subnet 2, the address will be 172.16.128.0, the mask will be /18, and it will assign to LAN B. And for the last subnet is subnet 3, which is the address will be 172.16.192.0, and the mask will be /18, and it will assign to the server network. So next is how to calculate the binary and decimal value for network address and broadcast address. So for our LAN A is 172.16.64.0/18. We have the value of the decimal and also the address type. So we just need to change the value into the binary value, which is the 32 bits. So as you can see here, there's a table. It already convert it to the 32 bits. And for the next one is LAN B, 172.16.128.0/18. It also has been converted to 32 bits. And also the server network 172.16.192.0/18, and the one link, which is the 172.16.0.0/30, it also has been converted to the 32 bits. And the subnet mask for LAN A, LAN B, and server network, which is the /18, equals to 255.255.192.0. We have concluded the full binary, full decimal, and also CIDR notation. And for the next one is the subnet mask for one link, which is the /30, equals to 255.255.255.252. We have concluded the full binary and also the full decimal and CIDR notation, which is /30.
So up next is the complete subnet table. As you can see here, this table shows the 4 different subnets with the number starting from 0 all the way to 3. The network of 172.16 was split into 4 subnets, and the first subnet, which is subnet 0, has only 2 hosts, which matches the router 1 to router 2 link, while as subnet 1, 2, and 3 all supports 254 usable hosts. Next is our group project verifying connections. As you can see here, first up we have the scenario in which the PC pings its default gateway, which is successful with no loss, showing that the configuration of the gateway, default gateway, is correct. Up next is the scenario in which we are pinging from a different LAN subnet, meaning a PC from LAN A to a PC from LAN B. As you can see, it is also successful and shows that the packet crossed one router exactly. The next scenario is which that we are pinging the PC that are in the same LAN. So this is from PC in LAN A to PC in LAN A also. So here, as we can see, it is successful with the TTL value to 128 with no loss. Up next is the pinging a server using a PC. So this is a PC pinging its own server. So this shows that the packet crossed two routers in order to get from the PC to the server. Lastly, it is the pinging from PC to its own ISP router. Now this shows that the TTL value is 254, and it shows that the packet crossed one router in order to reach its ISP, and that there are zero packet loss, which means that it is successful.
First thing first, our project is looked at here. This is start topology. We use the one server, three router, two switch. For the router 1, we name it as the R1. For the router 2, the name is R2, and the router 3, which is the ISP. The name is Internet Service Provider. Now, I will show you the configuration testing for our router 1. Now the password is go one okay, first enable the password is class. Now I will show you the connection for our router. Show IP interface brief. Okay, now we will look at here. The gigabit internet 00 is up, gigabyte internet 01 is up, serial port is up, and the conclusion, the router is established connection for the each cable. Now for the R2, we look here. First enable show IP interface brief. Show IP interface. Okay, now as we look at here, the gigabyte internet is up, and for gigabyte internet 01 we don't use it. For the serial port is up. For the serial port 001 is up. The 001 port is connection to the ISP. For the ISP, we can look at here. The gigabyte 00 is down. Gigabyte 01 is down. Serial port 001 is down, and serial port 001 is up. 0 is down, 0 is up, which is the serial port 001 is connected to the R2, and the connection is established. Now I will show you the IP for each router. For the router 1, the IP is 172.168.4.1. For the router 2, the IP is 172.168.192.1. For the ISP, the IP is 09.169.165.200.227. For the server, the IP address, we static it to 172.168.192.1. This is the subnet mask, this is the default gateway, and this is the DNS server. Now for the ping testing, I will choose randomly at the PCA3. Go to the desktop, and I will show the IP config. And the IP for the PCA3, this is the 172.168.64.14. Okay, the first test, I will ping the same LAN. For the S2, this is LAN A. S1, this is a LAN B. Now for the PCA4, I will find the IP address, IP config. And the IP address for the PCA4 is 172.168.64.16. Okay, now I will ping it. ping 172.16.64.16. Okay, now we will look at here. The ping is successful because the packet sent is 4, receive is 4, and loss is 0%. Okay, the first test is successful. Now we will go to the second test, which is I will ping from the LAN A to the LAN B. Okay, for the LAN B, I will choose the PCB4. PCB4. First, we look at his IP, and the first we will show the 172.168.10. Okay, now I will ping it. Ping 172.16.128.10. Okay, now we will show the ping from the LAN A to the LAN B. The latest time up at the first, I think this is normal because which is the is go to cross the LAN from the router to the switch, and but this is also success. The 3 receive and 1 loss, only 1, which is 25% loss. Now you will try to ping the server. First we look at the server IP. CA3, CA4, CA3. Okay, now ping 172.16.192.2. Okay, now if we show the ping and the ping also success, this is show our connection is connect and established. And now I will go to the service and look at the DNS. Now we will go to ping the DNS name, which is ping ITT300 August 2026.uitm.edu.my. Okay. Okay, now the ping also success because the connection ping before is also connect. Now to know our connection is true or not, we use the PCA4 or PCA3. Go to the web browser. The web browser is slow. We wait. Okay. For test the website, we use the domain name ITT300 2020 August 2026.uitm.edu.my. Okay, now the website go to our HTML. At the server, you add here, this is DNS, and for the uploaded file, logo UITM, team members image, and this is our index. For the now I will look the last thing, the DHCP configuration for LAN A, which is the switch S2. The network, the IP is the DHCP, which is all the PC at here will get the randomly IP address. Also the LAN B, which is S1. This is also the DHCP, which is the IP we will get the randomly from the server. Okay, that's all. Thank you. Before the outcome is this is our logo ATM, our team members face, and also the page. That's all.